Alright, so today we are going to verify identities using basic definition of trig function and using Pythagorean identities. So, a trig identity is an equation involving the trig functions that holds true for all values of that variable. So here's an example of a Pythagorean identity. We've got sine squared theta plus cosine squared theta equals 1. If that one is not already written down on your front side of your identity sheet, would you make sure it's there? It'd be to the left of that chart that you filled out on the front side, that table. I'm pretty sure it's there, sine squared theta plus cosine squared theta equals 1. So this means that for every unit pair, ordered pair there on the unit circle there, when your theta there is pi over 6, then sine squared of pi over 6 plus cosine squared of pi over 6 there is equal to 1. We can also, this is sometimes confuses people just because of the way that it's written. So let me rewrite this another way. This sometimes makes more sense to people. You can also write this as a sine of theta, whatever that value is, you square that, and then plus the cosine of theta squared equals 1. Now, we write it sine squared theta plus cosine squared theta equals 1 just because then you get to write less. You know how you have to now, I had to write extra set of parentheses in each case there, so it made it more writing. So that first way over here, this part over here, is a lot easier to write out. But kind of going through this, remember that on the ordered pair over here, this is the square root of 3 over 2 is your x value, and your 1/2 there is your y value. But remember on the unit circle, your cosine of theta is your x value, and then your sine theta on the unit circle is your y value. All right, so really, because this formula up here says sine squared theta plus cosine squared theta equals 1, I can take my 1/2 and plug it in there for sine theta and then square it. And then my cosine, I can go ahead and plug in the square root of 3 over 2 and square it. And that should give me 1 if that's true, if that holds true. So let me show that to you. So I can go ahead and take 1/2, because that's my sine. So it says sine squared plus cosine, which is a square root of 3 over 2, or your x value. That doesn't look like a 3. There we go. Squared. And that's supposed to give us 1. So let's see if it does. So if I square the 1, I get 1. If I square the 2, I get 4. If I go ahead and square the square root of 3, the square and the square root cancel each other out, and I get 3. And then 2 squared there simply gives me 4. So now I can just add my numerators. So that's the top number. So 1 plus 3, there's 4. And then write down the common denominator there of 4. And then I can simplify that, and that should give me 1, which is exactly what we said it would do. That sine squared theta plus cosine squared theta should give us 1, and it did. So that was true. So you already have these on the front side of your identity sheet. They're up at the top. These are the reciprocal identities. If you don't have these, it'd be a good idea to copy them down, but I'll just go through them again, and if you need to pause the video in order to get them written down, go ahead and do that. So cosecant of x is equal to 1 over sine x, or whatever value there you're using for your variable there, it doesn't matter. So whether it's x or y or theta or a, it doesn't matter. Secant of x is equal to 1 over cosine x. The cotangent of x is 1 over tangent x, which is the same thing as cosine over sine, and the tangent of x is sine x over cosine x. So fundamentally, trig identities, we've got this one, the sine squared x plus cosine squared x is equal to 1. We can also solve for cosine or for sine squared here. So if I do so, how I would do that, if I've got, I think you've got theta on yours, so I'm just going to rewrite this in terms of theta. So I can solve for sine squared theta, so I'd have to get rid of cosine squared. So I'd have to subtract cosine squared. So if I do that on the left, I have to do that on the right. So really, sine squared is just 1 minus cosine squared. And then if you look back up there, that makes sense then, that cosine squared theta, if you come back up here, the original one, and you subtract off sine squared instead of subtracting off cosine squared, you'd end up getting cosine squared. So sine squared, oops, got too fast there. Erase that. I'll try that again. So really this is 1 minus sine squared theta. And if you want to write this on the front side of your identity sheet, go for it. Okay? So if you remember, how did we get this Pythagorean identity here of sine squared plus cosine squared equals 1? If you remember when we talked about the very beginning there, because the unit circle here is centered here at 0, 0, and it has a radius of 1 there, then we said here that since that is true, our equation of our circle here is y squared plus x squared equals r squared. Right? Because it's centered there at 0, 0. Because the center of the circle there is 0, 0, we can write out our equation like that. And really, I should have probably written it the other way around, but I put it in this order because your sine and your cosine are in that order. It doesn't matter. I could have said x squared plus y squared equals r squared. Well, since our radius on our unit circle there is 1, we can go ahead and put a 1 in there for r. And then since it's the unit circle, we know that our sine of theta is equal to our y, and we know that our cosine is equal to our x. We can simply substitute those in there. So this goes sine of theta, because that's our y, and then we're supposed to square that. Plus our cosine, because x is cosine on the unit circle, squared, equals 1 squared, and 1 squared there is simply 1. So then we can rewrite this. A shortcut way of writing that is sine squared theta plus cosine squared theta there equals 1. So that's where that came about, because whenever you got a circle there and centered there at 0, 0, we can say x squared plus y squared on the left hand side, and then since our radius there is 1, we can say 1 squared, and 1 squared there is 1. And then substitute the sine and the cosine in for the y's and the x's. Alright, so now this is a little bit tricky, but it will go smoothly. You just got to kind of think about things that you know about math. So we are going to show that they're going to tell you what it starts off with to be, and they're going to tell you what it's supposed to look like at the end. You have to work on only one side of the equation. Pick on one side of the equation, whichever one you want to work with, and it has to get to the other side of the equation. You can't work on both sides of the equation. You just know what it's supposed to equal to. So here's a hint over here. It says usually it's easier to start with the more complicated side of the equation. So some things to look for is maybe look for the algebraic things to do. So if there's 2 terms and you only want 1, you might want to go ahead and add the fractions. You might want to factor something out. So if there's like a GCF in it, you might pull it out. you might want to go ahead and multiply by a form of 1. So maybe multiply the numerator and denominator by its conjugate. You might want to get the desired expression in numerator or denominator. You might want to do any obvious algebra stuff like use a distributive property, or you might want to square both sides, or you might want to square it, or you might want to multiply some polynomials. So those are some obvious things. So when I say squaring, you might want to FOIL something out, or you might want to just say if it's 2x squared, then you do 2x times 2x, some things like that. So then there's also the trig things to do. So if you've got 1 minus cosine squared theta, you might not want to now replace that with sine theta squared theta. Or if you've got a secant x, you might want to replace secant x because the reciprocal of secant is 1 over cosine. You might want to replace secant there with 1 over cosine. If you've got something like sine over cosine, then we know that sine divided by cosine there is tangent, so then you write down tangent x. So if there are squares or functions, you want to think about your Pythagorean properties, your identities there. So you want to think in terms of that sine squared plus cosine squared equals 1. So if you start to see those squares, you might want to do something with replacing those. And then you want to reduce the number of different functions. So usually we want to go ahead and make sure everything's in terms of sines and cosines. So you want to get them all down to either sines or down to cosines, because, and eventually, you know, it depends on what you wanted to get it to equal to, but you might need to get them all down to tangents or something like that. So keep looking at the answer to make sure you're heading in the right direction. And sometimes you mess up, you might have to start all over again, and have to do something differently. So let's go through this first one here, and just stay with me on this, okay? It's okay, you can rewatch the video, you'll start to understand it, you just got to try it. This is something you actually have to try out in order to understand it. So we want to go ahead and we want to verify the identity here. So the simplistic one here is on the right hand side here, and I want to get the left hand side here to match the right hand side. So I'm going to work on this more complicated left hand side and see if I can get it to look like the right hand side. So since this term over here is just a single term here, I might go ahead right away here and use my distributive property and distribute the cosine through. So I might do that first. So if I distribute it through, I'm going to get cosine theta times secant theta. So I chose an algebra thing to do. Could you have done something before this? Yeah, you might have changed some things instead. You might have changed that secant into 1 over cosine first. But we're going to do that next, most likely. So all I did was distribute the cosine through. I'm not going to write down on the sine squared theta here. So I'm just working on the left hand side right now and trying to get it to look like the right hand side. So now, since this is just in one on the right hand side, see how that's just sine squared theta there? We want to go ahead and get it just to look like sine squared theta. So the next thing I'm going to do here is I'm going to rewrite the secant here in terms of cosine. All right. And then pretty much you want to do that. You want to rewrite anything that's not a cosine or a sine in terms of to get everything into sines and cosines. So I'm going to rewrite this secant here in terms of 1 over cosine. And you need to write out your steps. You can't skip steps on this. You'll get points taken off if you're not doing this. I already know it's supposed to equal secant squared, so I need to know that you know how to get there. So now I'm going to also look over here and I can see that cosine times cosine here is cosine squared. So I might do that next as well. So I can do a couple steps here at once, as long as, you know, the secant I changed to 1 over cosine, and cosine times cosine there I wrote as cosine squared. Alright, so now cosine is like it's over 1 here. So cosine times, multiplying my numerators, multiplying my denominators there, I get cosine theta over cosine theta, because 1 over cosine down in the denominator there, minus cosine squared. Okay, now cosine theta divided by cosine theta, that's like 4 divided by 4. What do you get? Something divided by itself? You get 1. So I get 1 minus cosine squared. So now do you see that that's an identity? I'm starting to see, oh, I've got 1 minus something, or I've got something plus something equals 1. Well, that's usually you're trying to think, oh yeah, that's one of my identities. This is your Pythagorean identity. What is 1 minus cosine squared theta? It is sine squared theta. You got to trust the process as you work through the algebra and the trig stuff. You want to change anything that's not a cosine or a sine into cosine or sine. Like I rewrote that secant, we wrote it as 1 over cosine. We also use a distributive property, use an algebra thing. We also multiplied cosine times cosine there and got cosine squared. And then we multiplied these over here together and got cosine over cosine. Replace that with 1. And then 1 minus cosine squared there gave us sine squared. So since I've got it down to what I want to do, I always kind of put a little check mark by it. All right, let's try another one. If you need to rewatch that, go ahead and rewatch that. So if at all possible, I'm going to change things into sines and cosines. So in this first one here, this is already sine, and the more complicated side is this left-hand side. The simple side over there is 1. We know that we want to get this down to 1. So all I can see right now, well, the first thing I see is, oh, let's just change everything in terms of sines and cosines. So secant there is 1 over cosine. And again, you can use the top part of your identity sheet there on the first side there if you can't remember what they are. And then I'm going to put sine over 1 here. And then down here, my lines aren't so straight there. All right, so tangent there is sine over cosine. All right, so I'm just working on this left-hand side here and getting it so it looks like the right-hand side there. That's all we're doing. That's all we want to do. So the next thing I can think about up here is to go ahead and multiply my numerator and denominator up there. Oh yeah, that is sine x over cosine x. And then down here, it's divided by sine x over cosine x. And then I can do the algebra thing now. Oh yeah, I got a fraction divided by a fraction. So I could just go ahead and go, oh yeah, sine x over cosine x times the reciprocal of what's down in the denominator. And then you can see everything is going to cross out here, right? If you're going to cross things out, make sure that it's legible. So this is 1s, and these are 1s. And so then 1 times 1 there, it's very easy. You just simply get 1. So, done. So again, if you don't know what to do, change things in terms of sines and cosines. So let's try another one here. Let's change everything in terms of sines and cosines here. So sines and cosines here. So secant there is 1 over cosine. And since it's a squared, I'm going to say cosine squared. So 1 over cosine squared x is the same thing as secant squared x. Minus 1 all over. Change everything into cosines and sines. Alright, so since everything right now is in terms of cosines and they're cosine squareds, I'm going to replace that 1 up there. I need to get, because I've got I've got 3 division bars in here, so I need to get this down to, a single term in here. So I need to get a common denominator up there in the numerator up there, and then write that as a fraction, and then go ahead and probably use my algebra skills there to rewrite that in a multiplication statement instead of division statement. So that's what I'm going to work on here. So I'm going to work on the numerator up there. I'm going to get my common denominator. It looks like my common denominator there because I can put this over 1 over 1. My common denominator is going to be cosine squared. So if I multiply my numerator and denominator with the 1s there, I can multiply this by cosine squared x. So I thought through on my algebra now, and this is 1 times cosine squared x. And then the whole thing. Don't skip your steps on here, because you skip your steps, you're going to mix yourself up, and then I'm not going to give you credit because I can't tell what you're doing. So keep it looking like exactly what the problem there looks like. It should look like a numerator and denominator together. So now up here in the numerator, 1 times cosine squared just gives you cosine squared. So up there in the numerator there, I get 1 minus cosine squared x. Over its common denominator of cosine squared x. And then, there we go. And then divided by 1 over cosine squared x. So now that I've got a fraction divided by a fraction here, I can write this down as a multiplication problem. So 1 minus cosine squared x over cosine squared x times the reciprocal of what's down in the denominator. So it was 1 over cosine squared x. Now it's going to be cosine squared x over 1. Now see if you can cross out anything that matches diagonally there or up and down. And I can see, hopefully you can see, this cosine squared x and this cosine squared x can cancel out. So now I'm just simply left there with 1 minus cosine squared x. But that's one of our identities. On the front side there, we know what 1 minus cosine squared x there is. It's sine squared x. And you might have changed that before this time than I did. Maybe you saw that way back, way back up here. You might have seen it, right here, or you could have seen it here and changed it. That's fine. So there we have it, sine squared x. And that's exactly what we were supposed to do here. We're supposed to have verified. So see how I changed everything? I changed everything in terms of sines and cosines. I got a common denominator up here in the numerator. I wrote the numerator and denominator as single fractions, and I rewrote it as a multiplication statement. I cross out the cosine squareds because diagonally there they could cross out. I end up with 1 minus cosine squared x, and 1 minus cosine squared x is an identity, and it's equal to sine squared x. Done. All right, so maybe turn off the video right now and just pause it right now and see if you can try out this problem here. All right, so now let's just go through this. So I'm going to work on the left-hand side and get it to look like the right-hand side here. So sine there is already, you know, in terms of sines and cosines, it's already there. Plus cosine theta. And then that cotangent, I might as well write that in terms of sines and cosines. So cotangent is cosine over sine. Right, I'm just going to remind myself, and I'm going to put a 1 down here so I don't mess anything up. So now the next thing I want to do here is I'm going to leave the sine alone for a minute there, and I'm going to work with that second terms there because it's the only thing I can really think about to work with right now. So all I see right now is that maybe I can multiply cosine times cosine there is going to give me cosine squared, and multiplying my numerators there together. Multiply my numerators cosine times cosine, multiply my denominators is a sine. So now I'm going to get cosine squared theta over sine. All right, so now I'm looking at the right-hand side, and I'm thinking, everything's in terms of sines and cosines on the left-hand side right now, as far as I have it. But on the right-hand side there, at the very beginning up there, it says there that, you know, that we're supposed to get down to cosecant. Well, in my brain there, I'm thinking, oh yeah, that's 1 over sine theta. So I know I need to get 1 over sine. And so, this stuff down here, I need to get a common denominator down there, and I'm going to get a common denominator of sine. So I'm going to put this sine over 1 here. So this first term over here, that sine theta over 1, I'm going to get a common denominator and multiply the numerator denominator by the sine of theta. Because I know I need to get this down to 1 over sine, so I might as well get a common denominator. So that's the only thing I can think of to do right now. So I'm going to go ahead and multiply the numerator and denominator of the first term there by sine theta. And then down here, and then my second term there doesn't change. So I would probably next is go ahead and multiply that sine times sine there. Because I'm starting to think, I'm starting to get something squared plus something squared. That's a good thing. So up here, if I now do this, this gives me sine squared theta in the numerator plus, since they got a nice common denominator of sine theta, this is cosine squared theta. And hopefully now you're seeing that that's going to be a Pythagorean identity. Remember we wrote this down as your Pythagorean theorem identity there that said sine squared plus cosine squared there. We had that equal a value. Do you remember what that is? And hopefully you're saying, yeah, that's 1. So sine squared theta plus cosine squared theta there gives us a value of 1 up there in the numerator. So now I can say, oh yeah, 1 over sine theta. And 1 over sine theta is simply equal to cosecant theta. Which, guess what? That's exactly what we wanted to get it down to. Done. So we changed everything in terms of cosines and sines on the left-hand side there. So cotangent there, we got it down to cosine and sine. Then we kind of remind ourselves what cosecant there was. It was 1 over sine. So then we thought, oh, we might better get a common denominator of sine. So we did that. We could then add the numerators there together, and we got sine squared theta plus cosine squared theta all over the common denominator of sine theta. And then we realized that that sine squared theta plus cosine squared theta was 1, so we get 1 over sine. And then we knew 1 over sine there was cosecant, so we were good to go. All right, so you are going to practice some of these. So there's your assignment. Go ahead and see if you can work those things through and think about the things that you can do. Change things on the one side in terms of cosines and sines, but bear in mind what you have to get to.